Okay, Assalamualaikum and good day to Puan Liza Suhana Binti Ramli, our beloved lecturer of subject Fluid Mechanics, DCC 30122. So for today's presentation, our group will be presenting the subtopic in the Fluid Mechanics, which is topic 3, the hydrodynamics. So firstly, my name is Muhammad Faris Haikal bin Muhammad Nasri, number matrix 16 DKA 19F1139. So I'm going to begin slide. Okay, so this is the group members. Okay, so the first one is me, Faris. Then Nopradon, Aidnozu Izati, Nofitra, Amirul, and Sharifuddin. So I'm going to tell you, explain about the topic. So firstly, what is hydrodynamic? So, hydrodynamics is a branch of physics that deals with the motion of fluid and the force acting on solid bodies, immersed in fluid and in motion relative to them. So basically, hydro is actually the fluid or the water, and then the dynamics is a movement or the flow of the water that force into that fluid move force acting in solid bodies and immersed in fluid. So mean the fluid goes in motion. So for the next, so we're going to talk about the flow visualization. So what is this flow visualization? The flow visualization, or known as flow visualization in fluid dynamics, is used to make the flow pattern visible. Okay, as you can see in the slide here, the flow of the visual flow in order to get qualitative or quantitative information on them. So basically, flow visualization is effective way to investigate the qualitative the dynamic behavior of carbon dioxide, gas bubble at anode channel, and liquid water drops at cathode. So it means the liquid flows and it form in that picture that I put there, which is the flow, the visual of the flow. Okay, so flow visualization also provide information on the whole flow field, immediately understandable without need for the data processing, since air and water are transparent. The flow field can be made visible only indirectly, and therefore the following techniques is needed. So the technique first is light scattering by gases, which is a solid or liquid particle seeded into stream. And the next is the behavior of material deposited on the surface of the body immersed in the flow. The third, change of the refractive index produced by change in density, which is the optical method. So I'm going to explain about the method of flow visualization. So this is the method. Okay, the first one is surface flow visualization, which as you can see in the slide, I put the picture. Okay, so this is the example of the surface based flow visualization. This reveals the flow streamline in the limit as a solid surface is approached. Colored oil applied to the surface of wind tunnel. Model provides one example, which is the oil, that responds to the surface shear stress and forms a pattern. It means that the method used, the base is the oil. So when it responds to the surface of water, it will form a pattern of the flow visualization. Okay. Next one is particle tracer method. Okay, so as you can see, the particle tracer method is used by the pulse laser, as you can see on the diagram below. The particles such as smoke or microspheres can be added to a flow to trace the fluid motion. We can illuminate the particle with a sheet of a laser light in order to visualize slice of a complicated fluid flow pattern. Okay, so that we can assuming the particle faithfully follow the streamline of the flow. We can not only visualize the flow, but also we can measure the velocity using particle image velocimetry or particle tracking velocimetry method. So it means that uh, we we cannot just see, we can just see the pattern of the fluid. We also can measure them using this method, which is the velocimetry and the particle tracking velocimetry. So the particle with densities that match that of the fluid flow will exhibit the most accurate visualization. Okay, so it goes to start from using the laser pulse to the beam focus optic, and the flow will directly goes to the laser sheet, and we came to the tracer particle displacement. So as you can see, there's a camera there. Okay, which is the particle velocity, which you can measure the flow visualization. So the next one is optical method. So optical method review the pattern by the way change in the optical refractive index. These are visualized by optical method known as shadowgraph, Sheeran photography, and interferometry. Interferometry. More directly, dyes can be added to usually liquid. Okay, dyes is actually like a color that different from the usual liquid that we use to flow the flows to measure concentration, typically employing the light into attenuation or laser induced fluorescence technique. So this technique also use a laser. Okay, you see the put the CD tube there, and there's a CD camera there, and also pitching a foil. So the laser in the side of the particle, and also oscillating device. Okay, so the next one is the real fluid and ideal fluid. So what is real fluid? Real fluid is the that possess the viscosity term a real fluid. This fluid always offer shear resistance, while ideal fluid, which is don't have viscosity and are incompressible, which is different from real fluid. The real fluid is compressible, and a term and the ideal fluid term such as fluid do not offer shear resistance. Okay, so the real fluid is always have we call the laminar flow, which is the water in a pipe goes smoothly and it flows steady, while ideal fluid could have a turbulent flow, or we call turbulent, which is this pipe has it's like a small gap. Okay, in the turbulent, when the water goes very fast, so it is not ideal as the real fluid.
Hi, Assalamualaikum. My name is Ainus Izati binti Zulkifli. I want to explain about compressible and incompressible flow. A fluid are compressible so that their density will change with pressure, but under steady condition flow, provided that change in pressure are small, we usually say the fluid is incompressible and it has constant density. However, in unsteady flow condition, high pressure difference can develop and the compressibility of liquid must be taken into account. These are in general two types of fluid flow in pipes, which is laminar, turbulence, and transition. Laminar flow. Laminar flow generally happens when dealing with small pipes and low flow velocities. In laminar flow, the motion of the particle of fluid is very orderly, with all particles moving in straight lines parallel to the pipe walls. Next, the turbulent flow. In turbulent flow, vortices, eddies, and wake make the flow unpredictable. Turbulent flow happens in general at high flow rates with larger pipes. Next, transitional flow. Transitional flow is a mixture of laminar and turbulent flow with turbulence in the center of the pipe and laminar flow near the edges. Each of these flows behave in different manners in terms of their frictional energy loss while flowing and have different equations that predict their behavior.
My name is Nopradon Anak Laki Pramuan. My matric number is 16 EKA 19F1016. Today I will be presenting about uniform flow and steady flow. Uniform flow. Flow is said to be uniform when the velocity of flow does not change either in magnitude or in direction at any point in a flowing fluid for a given time. For example, the flow of liquid under pressure through long pipeline with a constant diameter is called uniform flow. Non-uniform flow. Flow is said to be non-uniform when there is a change in velocity of the flow at different points in a flowing fluid for a given time. For example, the flow of liquid under pressure through long pipeline of varying diameter is referred to as non-uniform flow. Steady flow. Fluid flow is said to be steady if at any point in the flowing fluid important characteristics such as pressure, density, velocity, temperature, and etc. that are used to describe the behavior of a fluid does not change with time. The rate of flow through any cross-section of a pipe in steady flow is constant. Unsteady flow. Fluid flow is said to be unsteady if at any point in flowing fluid any one or all the characteristics describing the behavior of a fluid such as pressure, density, velocity, and temperature change with time. The rate of flow through any cross-section of a pipe is not constant. Steady uniform flow. Conditions do not change with position in the stream or with time. For example, flow of water in a pipe of constant diameter at constant velocity. Steady non-uniform flow. Conditions change from point to point in the stream but do not change with time. For example, flow in a tempering pipe with constant velocity at the inlet. Unsteady uniform flow at a given instant in the time. The conditions at every point are the same but will change with time. For example, a pipe of constant diameter connected to a pump pumping at a constant rate, which is then switched off. Unsteady non-uniform flow. Every condition of the flow may change from point to point with time at every point, such as wave in a channel.
Hi, Assalamualaikum. My name is Nafika Shafika binti Nur Sham. I want to explain about closed and open system. I want to present about closed system. Its flow conditions, for example, velocity, pressure, cross-section, or depth are the same at every point in the fluid. Next is open system. Its flow condition may differ from point but do not change with time. The closed system is the system which can exchange energy with the surrounding but not the mass. The quantity of matter thus remain fixed and the system is described as control mass system. The physical nature and chemical composition of the mass of the system might change. Water may evaporate into steam, may condense into water. A chemical reaction may occur between two or more components of the closed system. Example, firstly, is water pump. Water enters at low level and pumped to a higher level, pump being driven by an electric motor. Secondly is scooter engine. Air array petrol enter and burn gas, leave the engine, and lastly is boilers, turbines, and heat exchangers. Fluid flow through them and heat or work is taken out or supplied to them. A system which can exchange energy with the surrounding but not the mass. The quantity of matter thus remains fixed, and the system is described as controlled mass system. For example, is car battery. Electric supply takes place from and to the battery, but there is no material transfer. Secondly, that is the kettle. The heat is supplied to the kettle, but mass of water remains constant. Thirdly is water in a tank, and lastly is piston, which is cylinder and assembly. Okay, hi, Assalamualaikum. I want to present about 1, 2, and 3 dimensional, which is term 1, 2, or 3 dimensional flow refers to the number of space coordinate required to describe a flow. And 1 dimensional, which is considered flow through a circular pipe. This flow is complex at the position where the flow enters the pipe. Okay, you can see this photo for 1 dimensional. Okay, next, the formula for 1-dimensional flow. It is readily seen the velocity at any location depends just on the radial distance r from the central line and is independent of distance s or of the angular position theta. This represents a typical on 1-dimensional flow. Okay, next, 2-dimensional flow, which is now considered a flow through a diverging duct as shown in figure 3.3. Velocity at any location depends not only upon the radial distance r but also on the x distance. This is therefore a 2-dimensional flow. And lastly is uniform flow, which is concept of a uniform flow is very handy in analyzing fluid flows. A uniform flow is one where the velocity and other properties are constant independent of directions. We usually assume a uniform flow at the entrance to a pipe far away from an aeroplane or a motor car as shown in figure 3.4. Thank you.
Assalamualaikum, nama saya Muhammad Syarifuddin Ajmal Bersyamsul Agama. Okey, apakah itu Reynolds number? Reynolds number digunakan untuk menentukan sama ada cecair itu laminar atau turbulent flow. Macam mana kita nak tentukan flow tu? Caranya ialah dengan anggaran nilai Reynolds number yang dikira. Jika ianya kurang daripada 2000, maka ianya dianggap laminar flow. Manakala jika ianya iaitu Reynolds number itu sendiri melebihi 4000, maka ianya ialah turbulent flow. Jika Reynolds number berada di antara laminar dan turbulent flow, iaitu lebih daripada 2000 dan kurang daripada 4000, ianya dipanggil transitional flow. Ini merupakan expression untuk mengira Reynolds number. RE iaitu Reynolds number sama dengan density darab dengan velocity darab dengan length ataupun diameter per bulk viscosity. Example: liquid is flowing through a pipe of 200 mm in a diameter, tube with mean viscosity of oil 2 meter per second. If density of liquid is 912 kg per meter cube and viscosity is 0.38 Newton second per meter second, decide the type of flow. Caranya ialah kita kumpul maklumat yang diberi, iaitu V velocity sama dengan 2 meter per second, D iaitu diameter sama dengan 0.314 meter second, manakala bulk viscosity ialah 0.38 meter second per meter cube dan density ialah 950 kg per meter cube. Kemudian masukkan maklumat ke dalam formula Reynolds number. Selepas mengira, kita boleh tentukan sama ada jumlah nombor Reynolds number ialah sama ada lebih daripada 2000 ataupun kurang daripada 2000. Contohnya macam ni, 1570 iaitu kurang daripada 2000. Maksudnya 1570 ialah laminar flow. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Amirul Akmal bin Helmi. Nombor kad matrik saya adalah 16 DKA 19F1175. Okey, di sini saya ada tampilkan satu persoalan, iaitu yang berbunyi a liquid flowing in pipe with velocity of 25 cm and diameter is 2.5 meter second, 2.5 meter per second, meters, and kinetic velocity 1.07 meter square per second. Calculate the Reynolds number and indicate the type of flow. Okey, kat sini tips untuk mudah menjawab soalan macam ni adalah keluarkan segala isi yang dia bagi. Okey, di sini saya mengeluarkan isi-isi yang dia bagi. Sebab apa nak keluarkan, saya suruh keluarkan isi-isi yang penting sebab kita akan nampak formula mana yang kita akan guna. Okey, diameter. Diameter yang diberi adalah 25 cm, tetapi dalam Reynolds number ni kita akan guna dalam meter. So kita convert ke dalam meter, 0.25 meter. Okey, simbol bagi diameter adalah huruf D kecil, di mana velocity simbolnya adalah V besar yang diberi adalah 2.7 meter second, and kinetic velocity simbolnya adalah V kecil yang diberi dalam soalan adalah 1.07 meter square per second. Okey, kita boleh nampak dah yang mana formula yang guna, iaitu RE. RE sama dengan V velocity diameter per kinetic velocity. So, masukkan dalam soalan, kita masukkan dalam tukan dari kan dia bagi dalam ni. Kita masuk boleh 2.7 darab 0.25 bahagi 1.07 darab 10 negatif 6 kuasanya darab 10 kuasa negatif 6. Okey, dapat jawapan 6308. So RE dia adalah lebih besar pada 2000. Ini bermakna flow is turbulent. Sekian, terima kasih.
Saya akan menerangkan tajuk pengaplikasian Reynolds number dalam kehidupan. Seperti setiap hari, kita sentiasa berhubung dengan fluid tanpa kita sedari. Kita dapat melihat sistem perpaipan dalam rumah kita. Fenomena ini dapat kita lihat dalam kehidupan seharian. Cecair yang keluar daripada paip akan berhenti secara tiba-tiba apabila kita menutupnya. Lepas tu, pusaran air yang kita lihat ketika di dalam tandas dikeluarkan melalui lubang tandas tersebut. Radiator air atau wap panas untuk memanaskan rumah dan radiator pendingin hawa dalam sebuah kereta yang bergantung kepada aliran fluid agar dapat memindahkan udara panas dengan efektif.
Okay, so for this final slide, I'm going to present about what is the application that used in a Reynolds number that related in our life. So Reynolds number plays an important role in the study of fluid mechanics, and today we shall study about the significance of Reynolds number and find out what it's used for. Okay, it is used when it's to modeling the movement of organisms swimming through water. Then the atmospheric air is considered to be a fluid. Hence, the Reynolds can be calculated for it. This makes it possible to apply it in wind tunnel testing to study the aerodynamic properties of various surfaces. It plays an important part in the testing of wind lift on the aircraft, especially in cases of supersonic flight where the high speed causes a localized increase in density of air surrounding the aircraft. Okay, so the Reynolds number is used also in industry of aircraft. Okay, the airplane. The resistance experienced by a wing in flight is a function of Reynolds number. Normally, the Reynolds number is the decisive factor in the airflow in determining whether the internal um, effect or the wins. Viscous effect wins. Okay, let's take a look what Reynolds number value roughly tell us about airflow and drag. Okay, the Reynolds number is large. The viscosity effect is small. If the Reynolds number is large, so the viscosity effect is small. Okay, for us to practical values, the inertia or density forces dominate and the parasite drag increase with the square of the velocity. Okay, however, although the viscosity is unimportant, it may still affect the very thin boundary layer, leading to the creation of turbulent flow. So it means that the importance of Reynolds number is that it tells the type of flow we can accept. It tells you that whether you can hope for having laminar flow over wing and other part of your airplane. A low Reynolds number give a laminar flow, while a high Reynolds number give a turbulent flow. For both laminar and turbulent boundary layer, increasing Reynolds number give a lower skin friction drag. However, because of higher energy loss in the boundary layer, a turbulent layer always has higher skin friction drag. So that is mean that the Reynolds number is important in use in modeling in wind tunnel. Okay, that use aircraft to study the aerodynamic properties. So that's it for me today.